Hello and welcome to my YouTube channel ChemWis. In this video we are going to discuss Woodward-Fieser rules for benzoyl derivatives. We have already discussed about Woodward-Fieser rules for conjugated dienes and alpha-beta unsaturated carbonyl compounds in separate videos. The link for them can be found in the description box of this video. The general structure of benzoyl derivatives can be drawn like this, where R is equal to H for aromatic aldehyde, alkyl group or ring residue for aromatic ketone, OH for aromatic carboxylic acid, and O-alkyl for aromatic esters. These are ortho, meta and para positions. Now we will go through Woodward-Fieser rules. First we will discuss base values. For aromatic aldehyde it is 250 nanometer. For aromatic ketone 246. For aromatic carboxylic acid 230, and for aromatic esters also it is 230 nanometer. Additions for substituents and ring residues at different positions. For an alkyl group or a ring residue at ortho, meta and para position, addition values are 3, 3 and 10 nanometer respectively. For hydroxyl group or alkoxy group it is 7, 7 and 25 nanometer. For O minus 11, 20 and 78. For chloro 0, 0 and 10. For bromo 2, 2 and 15. For NH2 13, 13 and 58. For NH-methyl 0, 0 and 73. For N-dimethyl 20, 20 and 85, and for NH-acetyl 20, 20 and 45 respectively. Now let's go through examples. Compound number 1, which is 2,4,6 trichlorobenzaldehyde. Base value for benzaldehyde is 250 nanometer. There are two orthochloro groups. Addition for two orthochloro will be 2 into 0 is equal to 0 nanometer. There is a parachloro group. Addition for one parachloro group will be 1 into 10 nanometer is equal to 10 nanometer. Thus the lambda max will be 250 plus 0 plus 10 is equal to 260 nanometer. Compound 2. This is an aromatic ketone. So the base value will be 246 nanometer. There is a ring residue at ortho position. The addition for one ortho ring residue will be 1 into 3 nanometer is equal to 3 nanometer. There is a bromo group at meta position. Addition for one meta bromo will be 1 into 2 nanometer is equal to 2 nanometer. Thus the lambda max will be 246 plus 3 plus 2 is equal to 251 nanometer. Compound 3. This is also an aromatic ketone. Base value for an aromatic ketone is 246 nanometer. There is an ortho ring residue. Addition for one ortho ring residue will be 1 into 3 is equal to 3 nanometer. There is an ortho hydroxy group. Addition for one ortho hydroxy group will be 1 into 7 is equal to 7 nanometer. There is a meta-chloro group. Addition for meta-chloro will be 1 into 0 is equal to 0. Thus lambda max will be 246 plus 3 plus 7 plus 0 is equal to 256 nanometer. Compound 4. This is an aromatic carboxylic acid. So the base value will be 230 nanometer. There is an amino group at para position. So addition for one para amino group will be 1 into 58 is equal to 58 nanometer. Thus, lambda max will be 230 plus 58 is equal to 288 nanometer. Compound 5. This is also an aromatic carboxylic acid. So, the base value will be 230 nanometer. There are two meta hydroxy groups. So, addition for two meta hydroxy groups will be 2 into 7 nanometer is equal to 14 nanometer. There is a para hydroxy group. So, addition for one para hydroxy group will be 1 into 25 nanometer is equal to 25 nanometer. Thus, lambda max will be 230 plus 14 plus 25 is equal to 269 nanometer. Compound 6. This is also an example of aromatic carboxylic acid. So the base value will be 230 nanometer. There is an orthohydroxy group. Addition for one orthohydroxy group will be 1 into 7 is equal to 7 nanometer. There is a para amino group. Addition for one para amino group will be 1 into 58 nanometer is equal to 58 nanometer. Thus, the lambda max for this compound will be 230 plus 7 plus 58 is equal to 295 nanometer. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much for watching this video.